So what are now the equal sets? What do you mean when we say that the sets are equal? If you say two sets, say we have a set A and set B, they are equal if every element of A is also an element of B and the vice versa is also true. That means every element of B is also an element of A. That is, the sets A and B are said to be equal. And we need to understand that the sets must have exactly the same elements. So if two elements are equal, we represent them by A equal to B. Otherwise, if they are unequal, we say A not equal to B. Just consider an example, that is, this is a set A and this is 1, 2, 3, 4. Again, we have a set B, 3, 1, 4, 2. We say A equal to B, because even if the arrangement is not equal, the members should be equal. So 1, 2, 3, 4 or 3, 1, 2, 4, these two correspond to exactly same set, right? And if you take one more example, that A is the set of prime numbers which is less than 6, and this P is the set of prime factors of 30. And as you see, A and P, they both have same elements like 2, 3, 5. So they both are similar. And one more thing we need to understand, that the possibility of this 2, 2, 1, 3, 3, what does it mean? It means that this 2, 2 is repeated, but we have taken 2, 1 here. We don't want any this repetition or duplication. So in this case also, these two are exactly similar. Now we'll take certain example. This is an example 7, and we want to find out which sets are equal or not. So A is 0, B is some number which is greater than 15 and less than 5. So can you find any number which is greater than 15 and less than 5? There is no number as such. So again, this actually is an empty set. This is an empty set. This is see, x is such that x minus 5 is equal to 0. So x is equal to 5 is the solution. Here x square is equal to 25. So x can be minus 5 also, x can be 5 also. And the third or the last one, which is the E1, is this is an integral positive root of the equation x square minus 2x minus 15. And as you see, you'll get x plus 3 and x minus 5 as the solution. So you'll get minus 3 and 5 as the solution. And we want only integral positive roots. So it will be only 5. As I just told you that these are the solutions. And in this, you can only see that there are only two sets which are equal. X equal to 5, this one, and this E1. Why? Because we have discarded x is equal to minus 3. X is equal to minus 3 we have discarded, since we want the integral positive root. So only set C and E, they are equal, otherwise no one is equal. Next is example 8, that you have these sets. X is a set of letters of alloy and B is a set of letters in loyal. Can you tell me, are they equal? This X set has 2L, this set has 2L, but as you see, if we just remove 2L by 1L, these two are exactly similar, only the order of the elements of the set are different. But as we suggested earlier, that these two are exactly equal. So X is equal to B. Now this set, minus 2, minus 1, 0, 1, 2, and you see this is 1, 2, but apart from this 0, minus 1, minus 2, they are not found here in this B. So we say that A and B, they are not equal. They are not equal sets. Next subset. See, imagine that X is the set of all students in your class, Y is set of all students in your class, and say you have one more set, say B, which is the set of boys, and then G, set of girls. So the set of boy or B or G, it is actually a subset of your class, and in turn this your 11th class is actually the subset of this X, which is the set of all students in the class. We represent this subsetting by this sign. This is our subset sign. So we say that y is a subset of x. So y is a subset of x. Here we write like this: y is a subset of x. Okay, y is a subset of x, and in this similar manner we can say that this implies means x is the superset of y. So what we say here is because all the boys or girls or the class members, they lie or they are inside this major set. So we say that if any element, say any boy you take, yourself you take, so you belong to A, that means you belong to your 11th class, you also belong to the school. So A belongs, or A is a subset of B when A belongs to capital A and A belongs to, means that same element has to belong to both these sets. So we say that A is subset of B if A belongs to A, that should imply A also belongs to B, right? So in this manner we say that A is a subset of B if A is an element of A, which implies that A should also be present in B. And this is the if only sign. We say that A is the set or subset or proper subset. So these are the terminology you are going to see here. Let's take an example, or let me tell you first that this Q rational number, this is a subset of real number. So we said Q is a subset of R, and you say that if A is the set of all divisor of 56 and B is the set of all prime divisor of 56, again B is a subset of A. Take one more example. A is equal to 1, 3, 5, and you want another set to have odd natural numbers which are less than 6, and you see that 1, 3, 5 and these two are exactly similar. So A is a subset of B, and in turn B is a subset of A. So we say A is equal to B. So A is a subset of B, B is a subset of A, we say A is equal to B. In these two sets, you say that this does not belong to this Q. Why? Because A is actually lying here, but B is not here. So they are not subset, and vice versa is also true. So what about this proper subset? See, if this 1, 2, 3 lies in this set B, 1, 2, 3, 4. So 1, 2, 3 exactly lies inside this B. We say that A is a proper subset of B. One more thing I would like to highlight is the singleton set. Singleton set means a set which just have one element. This is singleton set. Okay, singleton means one set. Let us take an example now. This is 5. This is empty. A is 1, 3, B is 159, and 1, 3, 5, 7, 9 is C. So we have to put sign here. 5 belongs to B. So all the sets will have subset as 5. Or this empty is the subset of every set. So first is, this is a subset. Second is A is a subset of B. Can you find 1? Yes. Can you find 3? No, I cannot find 3. So A is not a subset of B. Let us take A and C. 1, 3, 1, 3. Yes, I can find 1, 3 here. So I say A is a subset of C. Let us take this one. 159. Can you find 159? Yes, I can find 159. So B is a subset of C. In this case, A, E, I, O, U, B, A, B, C, D, because I cannot find E here, A is not a subset of B. And in the return case, I cannot find B here. So B is not a subset of A either. Then this A, B, C are three sets. Say A belongs to B and B is a subset of C. Is it true that A is a subset of C? If not, give an example. So the answer is no. Let us take an example. A is this set. Now B has two elements. One is actually the set A, which you see here, and this C has three elements, which is set A and comma 2, 3. So here you can see A belongs to B and A is 1 and B is a subset of C, but A is not a subset of C, as 1 does belong to A but 1 does not belong to C. And you can see that an element of a set can never be a subset of itself, an element, right? So subset of this real numbers, as we have just seen, the set of natural numbers is like this, set of integer is like this, set of rational numbers Q, which is of the form P by Q, is like this, where this Q is nothing but of the form P by Q, where this P and Q these are integer and q cannot be 0. And this member of q, this q, which includes -5 here in the previous case, as we see that various observations we can take that this, for example, this t, x may belong to r, x does not belong to q. So all real numbers that are not rational, all real numbers that are not rational, we say t, that is under root 2, under root 5, under pi, these are all irrational. So this is how we treat, and don't worry about this. If you don't understand, we'll be taking a lot of questions on this. Okay, so we just go back and take few more discussion on this, as we have just seen this subsetting. So let me conclude by saying that a set is a subset when it belongs to its superset, or the elements belong here, all the elements belong here, and two sets are equal only when the element exactly elements of A are equal to B, and if there are duplications, we don't bother, as we have seen here the subsetting also, and we have taken some examples also. These are the questions. So we'll be taking few more of this in the coming discussion. So till then, thank you so much. We'll be taking this intervals, etc. shortly. So thank you so much. Take care of yourself.